Hello, math fans. In this video, I'm going to talk about one of my favorite stories that I read to my kids when they were little, this book called Hippos Go Berserk. And whenever I read it, I would think about this famous mathematician, Gauss. And so I would like to connect these two things and let you in on what I was thinking and show you along the way some interesting kind of history of math, and also pay homage to Sandra Boynton, who I love with a deep passion. I'm mostly making this video for my nieces and nephews, of which I have many, but especially the young ones, Anna, Edison, Ty, Max, Cal, Jude, Cam, Maya, my own kids, even the older nephews, Ethan, Zachary, Alexander. This is for all of you. I hope that you enjoy reading. I hope that you see how much school and education has meant to me. And I just hope this is something where I can say how much I care about you. Anna was, during the pandemic, was with us and at home while we were, her mom was off being a nurse. And so I think of her as one of our own. And she had to endure a lesson. So one last lesson from Uncle Andy here. So I'm just going to talk about this story of adding up numbers and how it has this historical significance. But what I'd like to do, and I apologize for this, is I'm going to read Hippos Go Berserk to you. So apologies for anybody that's in my classes watching this video. You thought you were going to get help with calculus. No. So I'm going to read Hippos Go Berserk and just talk about it. I'm going to end this video with a discussion about Sandra Boynton, a little bit of research. But ultimately, I'm going to talk about adding up numbers. Okay, so here's Hippos Go Berserk. Let's quickly read it, and then if you'll stay with me that long, we'll get into the story and how it maybe connects with this famous mathematician when he was 7 years old. All right, here we go. So Hippos Go Berserk by Sandra Boynton. This was her first book she ever wrote. One hippo all alone. It'll be quick. One hippo all alone calls two hippos on the phone. 3 hippos at the door bring along another 4. 5 hippos come over dressed. 6 hippos show up with a guest. 7 hippos arrive in a sack. 8 hippos sneak in the back. 9 hippos come to work. All the hippos go berserk. We would spend a lot of time searching for the hippos when our kids were little. All through the hippo night, hippos play with great delight. But at the hippo break of day, the hippos all must go away. 9 hippos and a beast join 8 hippos riding east. 7 hippos moving west leave 6 hippos quite distressed. Always felt bad for these hippos. I don't know when these hippos leave, but 5 hippos then set forth, with 4 hippos headed north. 3 hippos say good day. The last 2 hippos go their way. 1 hippo alone once more misses the other 44. Lovely story. Thank you so much for all your books, Sandra Boynton. I always thought you had to do some adding when you wrote this book. You figured out that if you add up 1 through 9, you get 45. And you had to realize that when the 1 was left over, there were only 44. That's something Gauss did, but there's a story to go with that. All right, so now for some math. Thank you for listening to my story. So now for a little bit of math. So before I do that, I thought it would be interesting. I sort of copied a few things here. I'm going to turn into a little bit of a math teacher. So what I'm talking about here is one, oh, we need a better color. Not prepared, Uncle Andy. 1 plus 2 plus 3 plus 4 plus 5. And so you might say that's just adding. And you should also know that 6 is what comes after 5. Plus 7 plus 8 plus 9. That's what this book tells us. So I'm going to tell you a different story in a second. And you can try that on your own. I encourage you to see if you can add that up, without a calculator. For actually kids, that's easier. For adults, it's harder because we don't do stuff like this. At some point, you lose your willingness to do this. So I bet that Anna and Cal and Jude and Edison, you probably can do that easier than your parents can because they're going to reach for their calculator or their phone. But anyways, what I always thought about with this is, what if we increase the number? 1 plus 2 plus 3 plus 4, and went all the way to 100. At some point, you're not going to want to reach for that calculator. It turns out patterns like this are extremely valuable. They come up in my calculus class. I have a review sheet I've made on it. And there's lots of interesting questions. Okay, now I'm going to tell you a different story. So Gauss is one of the most famous mathematicians of all time. Isaac Newton was about the 1600s, the guy who invented calculus. Gauss came about 70, 100 years later, but did all sorts of things, discovered planets and various things. But there's this story, and it may not be true, and I'm going to completely embellish. But when he was 7 years old, which probably means he was in first grade, his class was being unruly. And I made this years ago. The teacher was like, can you guys just be quiet? And you have to remember, at this time, there were no calculators. They all had a little rectangular chalkboard and a piece of chalk. And the teacher was like, I need you guys to be quiet for just a few minutes. You keep talking. I don't know what they're talking about. They can't be on their phones. They didn't have phones. But they were talking unruly, and the teacher said, all right, everyone quiet, or I'll paddle you, but I want you just to add all the numbers from 1 to 100. And that snotty little Gauss immediately walked up and said the answer. What did he do? So he did 1 plus 2 plus 3, and he added up all the numbers up to 100. And he immediately walked up and just wrote on his chalkboard 50-50. How did he do that? Well, he spotted a pattern. And there are many proofs for this pattern. But that's what mathematicians try to do. We try to explain why things work, see if we can ask more general questions. One proof goes like this. And I kind of like this one. I'm going to write the numbers again. There's 100, here's 99, here's 98, and I'm just going to keep going. If you were here with me, I would say there's a 4, there's a 97, and I probably have lost some of you already, but that's all right. Here's a 1, and I'm going to add these side by side. 101, 99 plus 2, well, that's 101. 3 plus 98, well, that's 101. Well, that's 101. That's kind of interesting. And there's 100 of those. 101s. Now, Anna, I know you're doing some multiplication. That's a pretty big multiplication. But if you have 100 copies of 101, we call that 100 times 101. And it turns out that we can do. Now, you may not have done that yet in your classes, but you just add 2 zeros. There we go. I don't know how Gauss did it. I didn't have a chance to talk to him. I am pretty old, but not quite this old. Getting older every day. But this right here is not what we wanted. I just did 2 copies of it. Well, hold on. 2 copies of the same thing. This must be twice what I wanted. So he divided by 2. An interesting thing, if you divide by 2, I don't know if you've gotten to do any long division yet, but 2 goes into 10 5 times. And I hope when you do math, you make lots of sound effects like I do. It goes into 1 0 times. It goes into 10 5 times, and the 50-50. Gauss figured out even more. He said, now hold on. If you add those numbers up, you get 100 times 101 over 2, and that is the sum of these numbers. I'm probably getting into my head because I'm new to this recording thing. You need the other uncle in the family who knows how to do videos and at someday will tell me how to do this better. He figured this out. So what we do in math is try to generalize these things and see if we can do it more general, see if we can handle a tougher problem. So let's go back to Sandra Boynton's problem. Let's go back to the hippos and add up all the hippos from 1 to 9. And see if you can spot this pattern. So if we go up to 100, there were 100 copies of 101. See if you can play the same game we just played. And see, I can't even do it. Bum, 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 bum. More sound effects. We have 10, we have 10, we have 10. We have 9 copies of 10. That's 9 times 10. But I need to divide by 2 because I've double counted. Ooh, I'm starting to see a pattern. And oftentimes in math classes and in schools, we give you those patterns, which hides the real beauty of all the time that was spent experimenting. All the Gausses and the Boytons and the books and the things we thought about to get to that pattern. At some point, we then add things in there. There's all sorts of visuals of this, and there are many things I can do. This is basically what we're doing. We're lining things up. Sometimes these are called triangular numbers because you're doing 1 plus 2 plus 3 plus 4 plus 5. That's we call it a triangular number because it makes a triangle. So 1 is a triangular number, 3 is a triangular number, 6 is a triangular number. I know we're weird, but it's kind of nice to organize things. 15 is a triangular number. 45 is a triangular number. So at some point then, if you go on, people are like, well, I'd like a shorter way to write this. I'm sick of the ... So you get into classes and people get scared of the symbols. But we're just trying to organize what we're saying, and we get this cool pattern, n times n plus 1 over 2. And it's usually at some point in there, students' heads start to explode and we lose people. But we shouldn't lose them because it's, that's the game. There's patterns for squares, there's patterns for cubes. These are much harder to show, but it can be done. I used to challenge students to try to find the pattern for fourth powers. We don't use these regularly, but I love the story and the background, and these sorts of things pop up in proving other things. And it's not some sort of, maybe Gauss was a genius, but it's just logical thinking and putting things together. It's small things and organizing. So there's Gauss. So anyways, let's check our formula here. We have this formula that says, what should it be? It should be 9 times 10 divided by 2. It should be 90 over 2, and it's 45. So there you go. A challenge to the person watching this video. What if you add up all the numbers from 1 to 1,000? Or what if you add, why do I have to pick a round number? What if you add up all the numbers from 1 to 43? You could do it now. It's 43 times the next one, 44, divided by 2. And if you understand the idea, you can come up with it. You can know how many house guests are there. Okay, a few little things. Maybe I'll say the Gauss thing first. Gauss was a German mathematician. He's credited with, at the time, mathematicians would do lots of different things. Like he found planets, and I mean, it's amazing. This is a time without phones, without computers. All the calculations were by hand. So it's impressive the work he did. foundational for a lot of modern things we do and deal with. Probability, it's a long list of things, physics, geometry, but foundational ideas. And many say he's one of the greatest mathematicians of all time. On the flip side, Sandra Boynton, I think, is one of the greatest children's authors of all time. I looked up a little research on her. I'm quoting from an article I found. But what I found interesting is I didn't realize that Hippos Go Berserk was written in 1977. It was her first book. It said that she did greeting cards before and wrote songs and other things. But she was meant to make children's books. But I thought this was funny. I read this a little bit about some history. Why are the hippos so eager to socialize? A close reading suggests that aside from the two to arrive, they haven't necessarily been invited. So her opinion was the rest arrived uninvited. And then I like this where it says, why do they go berserk? And Sandra Boynton says, I don't really have a theory. I just report on what happened. The ways of fictive 2D bipedal hippos are notoriously mysterious. So I found that funny. I mean, I don't know the reality of this article, but it sounds like it could be true. So I don't know what she thought about the adding. I don't think she'll ever see this video, but appreciate the book so much. And it always gave me this opportunity to think about adding numbers. We added the numbers from 1 to 9. Hidden in there was some famous problems and a little bit of folklore and mathematics about this mathematician. All right, hope you found that interesting. And to my nieces and nephews, love you so much. And I hope, if anything, this can put you to sleep. So your parents can get a break. Maybe you already fell asleep. So in that case, it's a success. All right, love you.